All right, word problems, contextual problems, specifically consecutive integers. So integers are counting numbers, and consecutive means in a row, so consecutive. So examples of 3 consecutive integers, so the most basic ones, 1, 2, 3, or if you started at 16, the next integer would be 17, and the next integer would be 18. Now any number, we can start at any integer, and we can call that n, all right? Now the next integer after that would be n plus 1, and the one after that would be n plus 2, okay? Consecutive even numbers, so 2, 4, and 6 are consecutive even numbers, or for example 12, 14, and 16. Algebraic examples, representation of 3 consecutive even numbers. The first one you're going to start off with 2n. The next one you're going to be 2n plus 2. And the one after that is going to be 2n plus 4. Okay? Note that this is 2 more than that, that's 2 more than that, but to go from 2 to 6, that's plus 4. To go from 12 to 14, that's plus 2. To go from 12 to 16, that's plus 4. So that's where the plus 2 and the plus 4 come from. All right. Now, odd numbers. I don't know why that says 4, but we'll go with 3. 3 consecutive odd numbers. So for example, 3, 5, and 7 are odd numbers. And 21, 23, 25, those are also odd numbers. Now again, how do you make a number odd? Okay, well if I have 13, how do I represent that as an algebraic expression? Well, the first thing we want to do is call the first number 2n. Now 2 multiplied by any number is going to equal an even number. Okay, so 2 times an odd number still gives me an even number. So at least we can get to where they're going to be even numbers. Now if the 2n is the first number, we need to make that odd. So 2n plus 1, 2n plus 3, 2n plus 5. Those are consecutive odd numbers. And if we want 4 of them, it's going to be 2n plus 7. Okay. So in consecutive number questions, if they're just consecutive integers, use these 3. If they're consecutive even integers, use those. And if you're the consecutive odd integers, use those. So let's do a question here. The sum of 3 consecutive integers is 126. So we need to look, are they even, are they odd, or are they just consecutive? They're just consecutive. So we're going to do n plus 1 plus n plus 2. Those are the consecutive integer algebraic expressions there. And the total is equal to 126. So collect your like terms here. N plus n plus n is 3n. 1 plus 2 is 3, and that equals 126. Now if we subtract 3 and subtract 3, we end up with 3n is equal to 123. Rewrite over here just for a little bit more space. Divide by 3, and n is equal to 41. So that's our first number. So the next two numbers are going to be 41, 42, and 43. And if you add those up, you do indeed get 123. Here's our next question here. The sides of a triangle are 3 consecutive odd whole numbers. All right, so we got to look in our chart and look at the odd ones. So 2n plus 1, 2n plus 3, and 2n plus 5. So 2n plus 1 plus 2n plus 3 plus 2n plus 5. That's going to equal 147. Collect your like terms. So we've got 6n plus 9. N plus 9 is equal to 147. And if we subtract 9, we get 6n equaling 138. And if you divide by 6, n equals 23. So that's our first odd number. So the next odd number is going to be 25 and 27. Next one we have even integers. So that's going to be 2n plus, we got some more information here we actually have to work through here. 3 consecutive even integers such that the sum of twice the first and 3 times the third is 172. Okay, so we've got the first number. Let's call 2n to make it even. The second number, let's call 2n plus 2. And the third number, we're going to do 2n plus 4. All right. The sum of twice the first and 3 times the third. So twice the first, so 2 times 2n, plus 3 times the third, so 3 times 2n. I'll make that a little neater. Is going to equal 172. So expand 4n plus 6n plus 12 equaling 172. So 10n plus 12 equals 172. Subtract 12, 10n equals 160, which means n is equal to 16. So if the first one's 16, the next one's 18, and the next one is 20. There's your answer.